Hello everyone, I am Balaji Rao. Welcome to BR Maths class. This is second class in Relations and Functions, class 12th Mathematics. This is second concept. In this class, what we are going to learn? What is reflexive relation? What is symmetric relation? What is transitive relation? These are very important concepts in this relations topic. Many students confuse a lot to understand these things, but I'll give clear explanation about each relation with more number of examples so that all doubts will be clear in this class only. To understand exercise number 1.1 problems in these relations and functions, understanding these definitions is very important. Let's see what is the definition of reflexive relation. You see, reflexive relation. A relation R on A. A relation R on A, what it means? It means that R is a relation from A to A. Right? This we discussed in last class. A relation R on A, that means R is a relation from A to A, is said to be reflexive relation. This relation is said to be reflexive relation. This is important for every, this is important, you don't take it lightly. For every x in set A, order pair x comma x must belongs to the relation. Then we say that relation is reflexive relation. You may confuse little bit here, but you can understand this easily with the help of examples. I'll take set A like this. Set A is 1 2 3. R is a relation on A means R is a relation from A to A. When we say R is a relation from A to A, when R is subset of A cross A. So I want to write A cross A now. If you want to write A cross A, how you will write A cross A? See, first I'll take set A 1 2 3 cross. Again I'll take set A 1 2 3 A cross A. How you will pair with? You take one element in this first set, you pair with all other elements in the other set, like 1 comma 1, 1 comma 2, 1 comma 3. After that you will take this element to 2 comma 1, 2 comma 2, 2 comma 3. Similarly 3 comma 1, 3 comma 2, 3 comma 3. You know that is A cross A. So I'll write A cross A now. This is A cross A. See, 1 comma 1, 1 comma 2, 1 comma 3, 2 comma 1, 2 comma 2, 2 comma 3, 3 comma 1, 3 comma 2, 3 comma 3. You must know how to write A cross A. Now, how many relations I can form on set A? The formula is 2 power number of elements in A cross A. That is what? 2 power 9. So, 2 power 9 means 512 relations we can form. Now, I'll take one relation. You observe, I considered a relation. Is it is a subset of A cross A? If it is subset of A cross A, then only we say that it is a relation on A. You see, order pair 1 comma 2, yes, it is there in A cross A. Order pair 2 comma 1, yes, it is there in A cross A. Order pair 1 comma 1, yes, it is there in A cross A. Order pair 3 comma 3, yes, it is there in A cross A. So it is a subset of A cross A. So this is a relation on A. I taken a relation or on A. Now I need to decide this relation is reflexive relation or not. What is the definition? You observe, this is important. Every x belongs to A, order pair x comma x belongs to R. First, you come to set A, not to the relation. You come to set A. R is a relation on A. Na? For every x in set A, you take 1 in this set A. You take 1 in this set A. Order pair 1 comma 1 is there in this relation or not? You see here, for 1 belongs to A, I am checking that 1 comma 1 is there in the relation or not. See, order pair 1 comma 1 is there. For 1 belongs to set A, 1 comma 1 belongs to this relation. Can I say that this relation is reflexive relation? Can I say this relation is reflexive relation from this? No. You need to check for every x in set A. Then only you can say that for every x in set A, if order pair x comma x belongs to R, then only we say that this relation is reflexive relation. Suppose 1 is there, 1 comma 1 is there. That means we say that this element passed reflexive test. Now we will come to the next element because they are asking for every element in set A. Come to the second element 2. For 2, 2 comma 2 is there in this. You observe, for 2, 2 comma 2 is there in this. No, 2 comma 2 is not in this relation. So actual condition is what? For every x in set A, x comma x must belongs to the relation. But here 2 is there in set A, but 2 comma 2 does not belongs to this relation. So we say that this relation is not reflexive. This relation is not reflexive. If you want to write the reason, you can write like this. Because for 2 belongs to set A implies 2 comma 2 does not belongs to the relation. Because of this reason, this relation is not reflexive. I hope you understand. Now, I'll name this relation as R2. You observe, it is a relation on A. When we say R is a relation on A, when this R is subset of A cross A. 1 comma 1 is there in A cross A? Yes, 1 comma 1 is there in A cross A. 2 comma 2 is there in A cross A? Yes. 3 comma 3 is there in A cross A? Yes. So this is subset of A cross A. So first point is it is a relation on A. Okay. Now is this relation is reflexive? Is this relation is reflexive? What is the condition? Condition is for every x belongs to A. This is important. For every x belongs to A, order pair x comma x belongs to the relation. You take here 1. 1 is there in set A. 1 comma 1 is there in this relation. Yes, it is there. That means we say that this element pass reflexive test. Okay. Now come to 2. 2 is there in set A. 2 comma 2 is there in this relation. Yes, 2 comma 2 is there in this relation. So we say that this element pass reflexive test. Okay. 3 is there in set A. 3 comma 3 is there in this relation. Yes, it is there. So we say that this element pass reflexive test. So finally what we say? We say that this relation is reflexive. And one more important point, as this relation is reflexive, while writing the answer, you cannot write that 1 belongs to A implies 1 comma 1 belongs to R. That's why this relation is reflexive. Like that, you cannot say. You can write like this. If you want to write why it is reflexive, for every x belongs to A, order pair x comma x belongs to R. That's why this relation is reflexive. Now I'll take one more example to understand this reflexive relation more clearly. You observe, I consider one relation and it is a subset of A cross A. 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2. Yes, all elements of R3 are there in A cross A. So this is a relation on A. Now I am checking that is this relation is reflexive relation or not. What is reflexive relation condition? For every x belongs to A, this is important. For every x belongs to A, order pair x comma x belongs to the relation or not, you need to check. Okay. Now, as this is a relation on set A, you come to this set A. Here, 1 is there in set A. 1 comma 1 is there in this? Yes. 2 is there in set A. 2 comma 2 is there in this? Yes. 3 is there in set A. 3 comma 3 is there in this set? In this set? Yes. Here some people will doubt. Here 1 comma 2 extra is there na? Because of that how it will be reflexive. That is not the question here. Here the question is this relation satisfying this condition or not. For every x belongs to A, x comma x belongs to relation or not. That much only. You see here, for 1, 1 comma 1 is there. For 2, 2 comma 2 is there. For 3, 3 comma 3 is there. So we can say that this relation is reflexive as it is satisfying the reflexive relation definition. So this relation is reflexive relation or not? Yes, it is reflexive relation. Now, like this, how many number of reflexive relations we can form? Total number of reflexive relations. We have a formula for that. You see, we have a formula for total number of reflexive relations on A. The formula is 2 power n of A whole square minus n of A. So, total number of reflexive relations formula is this one. In this case, how many number of reflexive relations are possible? Right? The set A contains 3 elements. Na? So number of reflexive relation on that particular set is what? 2 power n of A is 3. 3 square is 9 minus n of A is 3. That is 2 power 6. 2 power 6 is 64. Like this, on this set, total 64 relations. Here I written 3 reflexive relations. Na? Actually, we can form 64 reflexive relations on this set. I hope you understand about this reflexive relation. Now, we are going to learn about symmetric relation. Definition of symmetric relation. A relation R on A is said to be symmetric relation if for every x comma y belongs to R. You observe this point carefully. For every order pair x comma y belongs to R. Earlier, for reflexive relation, what we checked, for every x belongs to set A. But here in symmetric relation, it is not like that. For every order pair in the relation x comma y comma x also present in that relation, then we say that that relation is a symmetric relation. We'll understand this with the help of examples. You observe, I taken set A as 1, 2, 3. You know how to write A cross A. This is A cross A. Now, I'll take one subset of A cross A to check symmetry condition like 1 comma 2, 2 comma 1, 1 comma 1, 2 comma 3. You observe this is a subset of A cross A. So, this R is a relation on A. When we say this relation is symmetric, to check symmetric relation, we will check for every order pair in the relation. That means you come to this. This is 1 comma 2. For order pair 1 comma 2, for order pair x comma y, you need to check y comma x. That means for this order pair 1 comma 2, 2 comma 1 exist in this relation or not. In this relation, 2 comma 1 is there or not, you need to check. You look here, 2 comma 1 is there here. As 2 comma 1 is present here, from this you cannot say that it is symmetric. Why? Because you need to check like that for every order pair in the relation. Okay, actually what happened, this element passed the symmetric test. For 1 comma 2, 2 comma 1 exist in this relation. This element passed the symmetric test. Like that, you need to check for every order pair. For every order pair x comma y belongs to R, y comma x must belongs to the relation. Here you take the order pair 2 comma 1. 2 comma 1 reverse order like y comma x is 1 comma 2. Is 1 comma 2 is there in this relation? Yes, 1 comma 2 is there in this relation. So this element passed the symmetric test. I hope you are understanding, right? Now come to this 1 comma 1. See, x comma y comma x. For 1 comma 1, what is y comma x? Y comma x is also 1 comma 1 for this. I hope you are understanding. So here 1 comma 1 for this order pair, 1 comma 1 must present in this relation. Is 1 comma 1 is there in this relation? Yes, here it is. So this element also passes the symmetric test. One important point is this type of elements always pass symmetric test. So whenever this type of element comes, no need to check reverse order 1 comma 1, 1 comma 1 is there in this relation or not. 1 comma 1, 2 comma 2, 3 comma 3, x comma x, this type of elements always pass symmetric test. I hope you understand what I am saying, right? So this element passed symmetric test, this element also passed symmetric test, this element also passed symmetric test. Like that you need to check for every, right? So here 2 comma 3 is there at the end. For this order pair 2 comma 3, reverse order is 3 comma 2. Is 3 comma 2 is there in this relation? For 2 comma 3, 3 comma 2 is present in this relation. 3 comma 2 is not there in this. So this relation is not symmetric. When it is symmetric, for every order pair x comma y in the relation, y comma x also must present in this relation. Then only we say that this relation is symmetric relation. So what I'll write here, I'll name it as this R1. R1 is not symmetric. Why it is not symmetric? Because 2 comma 3 is there in this relation, but 3 comma 2 does not belongs to the relation. That's why we say that this relation is not symmetric. You observe I taken one relation on this set A. Is this relation is symmetric relation or not? How to check symmetric relation? For every order pair x comma y, y comma x is there in the relation or not, you need to check. So you come to this relation 1 comma 1. See, I said na a x comma x type elements a comma a 3 comma 3. This type of elements always pass symmetric test. No need to check. You see here this is like x comma y comma x is also 1 comma 1. 1 comma 1 is there in this relation means yes here it is. Yes here it is. So this type of elements always pass symmetric test. So come to this order pair. Is it passes the symmetric test? Yes. Come to this 2 comma 2. Reverse order of 2 comma 2 is there in this. This type of elements always pass the symmetric test. No need to check. Yes, this passes the symmetric test. You observe here 3 comma 3. Yes, this type of elements always pass symmetric test. For 3 comma 3, reverse order is also 3 comma 3. 3 comma 3 is there in this relation. So this relation is a symmetric relation. You please observe this relation. Is it is a subset of A cross A? 1 comma 2, yes it is there. 1 comma 1, yes it is there. 2 comma 2, yes it is there. It is a subset of A cross A. So this is a relation on A. Is this relation is symmetric on set A? Is this relation is symmetric on set A? How to check? You will check for every order pair in the relation. For every order pair x comma y comma x is there in that relation or not? You observe here 1 comma 2 is there in this relation. For 1 comma 2, 2 comma 1 is present in this relation? No. So this element fails the symmetric condition. If one element fails, directly you can write this is not symmetric. No need to check at the time these things. As 1 comma 2 for every order pair x comma y in the relation, y comma x also must present in this relation. Here, when you identified there is one order pair x comma y, for that y comma x does not belongs to this relation. In that case, directly you can say that that relation is not symmetric. I hope you understand how to check given relation is symmetric relation or not. As we have a formula for number of reflexive relations, this is the formula for number of reflexive relations. We have a formula for number of symmetric relations also. Total number of symmetric relations formula is 2 power n into n plus 1 divided by 2. In some other class, I'll discuss why number of symmetric relations is 2 power n into n plus 1 by 2. Now, transitive relation. Actually, it is a bit confusing to many students, but I'll give very good examples. With that, you will never say that transitive relation checking is difficult. Okay, a relation R on A is said to be transitive relation. A relation R on A is said to be transitive relation for every x comma y and y comma z belongs to R. You please observe this part. First, in the given relation, we will check x comma y comma z exist in the relation or not. Here, what point you need to observe x comma y comma z? You observe this first order pair ends with y, second order pair starts with y. Such type of order pair we'll identify in the relation. If such type of order pair exists in the relation, then we'll look that x comma z is there in the relation or not. X comma y belongs to R and y comma z also belongs to R. Then we will check that x comma z belongs to R or not. Right. Like that, you need to check that for every such pair of order pairs. You can understand this more clearly with the help of examples. You observe, I taken set A as 1, 2, 3, then I written A cross A. Now, I'll take one relation on this set. I request you to watch this transitive full thing so that you won't confuse. Okay, right? Now, I taken one subset of A cross A. See 1 comma 2, 2 comma 3, 2 comma 1, 1 comma 3, 1 comma 3. Yes. So, this is a subset of A cross A. So, this is a relation on A. Now, my question is how to check this relation is transitive or not. To check transitive relation or not, first you need to look for x comma y comma z exist in the relation or not. If such pair doesn't exist, x comma y comma z doesn't exist, in that case we say that it is transitive. right? Please try to catch this point. It is a catchy point actually. Many students confuse in this. If you identify x comma y comma z in the relation, then you look for x comma z. Further, we'll say whether it is transitive or not. In case x comma y comma z, we'll find x comma y. Respective y comma z doesn't exist in the relation. In that case, we say that that relation is transitive. With the examples, you will understand that more clearly. Now, how to check this? First, listen carefully. You check like this. First, you take one order pair. Okay, this is like x comma y. Now you see that this ends with 2, right? This ends with 2. Now you observe that any other starts with 2 other than this, any other starts with 2. You need to check here. Any other starts with 2? Yes. As this ends with 2, this starts with 2, this starts with 2. That means we are able to find x comma y comma z, right? Okay. 1 comma 2 is there. This ends with 2 and this starts with 2. So this is like x comma y comma z. You can understand this is like x comma y comma z. What is x comma z? X comma z is 1 comma 3. Is 1 comma 3 is there in this relation? You please check. 1 comma 3 is there in this relation here. Yes, yes, 1 comma 3 is there in this relation. So for x comma y comma z belongs to R, x comma z is present in this relation. So this relation is transitive. Can we say like that? No, you cannot say like that, because you need to check for every such pair of order pairs. For every such, you just checked only for these two, 1 comma 2, 2 comma 3, x comma z is 1 comma 3. You just checked only for these two. Like that, you need to check for every such pair. I hope you are understanding. So here, what happened? This ends with 2. This starts with 2. Yes, checked here. Now, you can observe this ends with 2. This one also starts with 2. So, this is also like x comma y comma z. I hope you are understanding. For every such order pair, you need to check. Okay, 1 comma 2, 2 comma 1. In this case, what is x comma z? X comma z is 1 comma 1. Is 1 comma 1 is there in this relation? Is 1 comma 1 is there in this relation? No, 1 comma 1 is not there in this relation. So because of this example, you can say that this relation is not transitive. I hope you understand. When it is transitive, we have to do so much of work. What is that? For every such order pair, you need to look that x comma z is there in the relation or not. When it is not transitive, actually things are easy. Why? Just give the counter example. In this case, 1 comma 2, 2 comma 1 is there in this relation, but 1 comma 1 is not in this relation. Therefore, this relation is not transitive. Like that, we can say directly. So, what we say finally, I'll name it as R1. R1 is not transitive. What is the reason? Because 1 comma 2 belongs to R, 2 comma 1 belongs to R implies 1 comma 1 does not belongs to this relation. 1 comma 2 is there, 2 comma 1 is there, but 1 comma 1 is not in this relation. That's why we say that this relation is not transitive. Now you observe I taken one more relation on A. 1 comma 2 is there in A cross A. 3 comma 1 is there in A cross A. So R2 is subset of A cross A. So R2 is a relation on A. My question is this relation is transitive or not? In this transitive, please observe all the examples, then only you can understand this transitive relation. Now, how to check this relation is transitive or not? First thing, come to this 1 comma 2, right? This ends with 2. Now, you check that any other order pair starts with 2 in this. No other order pair starts with 2. But actually, what is the definition of transitive relation? For every x comma y comma z belongs to R, if such order pair exists, then we look for x comma z. If such order pair doesn't exist, in that case, we say that that particular order pair passed the transitive test. Here you see, this ends with 2. Any other starts with 2. Nothing starts with 2. So in that case, we say that this particular order pair passed the transitive test, right? So for x comma y, we are unable to find y comma z. If y comma z exists, then we'll look for x comma z, right? Okay. So this element passed the transitive test. Now Now you observe this 3 comma 2, right? 3 comma 2, this ends with 2. Any other order pair starts with 3 other than this ends with 2. Now you observe, is there any other order pair other than this which starts with 2? No. In that case, what we say? This satisfies transitive property. I hope you are understanding. If there exists x comma y, y comma z in the relation, then only we look for x comma z. Otherwise, we say that that particular element passed the transitive test. Here, when I am trying to check for this x comma y, y comma z exists or not, we didn't find y comma z. So in this case, we say that this element passed the transitive test. When it comes to this order pair x comma y, any other starts with 2 means there is no other starts with 2. So in that case, we say that this elements also passed the transitive test. So finally, we say that this relation is transitive. Many students confuse such type of examples. Please, you make sure that if for x comma y, y comma z doesn't exist. In that case, this passes the transitive test. Similarly, for 3 comma 2, no other order pair starts with 2 in this relation. So we say that this relation is transitive. So this relation is transitive. This is one of the best example to understand this transitive relation. You observe, I taken one relation on set A. When we say this is a relation on set A, you observe R3 is subset of A cross A or not. 1 comma 1, yes, 1 comma 1 is there. 1 comma 2, yes, it is there. 2 comma 3, yes, it is there. 3 comma 1, yes, 3 comma 1 is there. 1 comma 3, yes, 1 comma 3 is there. 3 comma 3, yes, 3 comma 3 is there. R3 is subset of A cross A. As R3 is subset of A cross A, we can say that R3 is relation on A. Now my question is this relation is transitive relation or not? One very important point. See, how to check relation is transitive or not. First, we'll take this 1 comma 1, and as this ends with 1, we look for any other starts with 1 or not. Like that, we'll start. But the thing is, whenever we are checking transitive relation for such elements 1 comma 1, 2 comma 2, x comma x, 3 comma 3, such type of elements always satisfies transitive condition. You see here 1 comma 1. This ends with 1. You observe any other order pair which starts with 1. Here this starts with 1. You look here 1 comma 1, 1 comma 2. What is x comma z in this case? X comma z is 1 comma 2. Now you observe 1 comma 2 is there in this relation. Yes, here it is. 1 comma 2 is there here. That's why this type of elements always satisfies transitive condition. You look here, I'll take x comma x and x comma z. What is the condition here? Transitive condition. This ends with x, this starts with x. What is the transitive condition? X comma z is there in this relation means x comma z always present in this only. You observe this x comma z, z comma z. This ends with z, this starts with z. When we look for transitive condition, we will look for x comma z. X comma z is there na here. I hope you are understanding. This type of elements always satisfies transitive condition. This type of elements always satisfies symmetric condition also. I hope you are understanding. So 1 comma 1 is there. This ends with 1. What are the other starts with 1? No need to check like that. Even though if you check, it satisfies. For example, I'll check here. This ends with 1. This starts with 1, right? Now, what is x comma z? X comma z is 1 comma 2. 1 comma 2 is there in this relation. Yes, 1 comma 2 is there in this relation. Okay, this ends with 1. Any other starts with 1? Yes, here it is there. It starts with 1. What is x comma z? X comma z is 1 comma 3. 1 comma 3 is there in this. Yes, here it is. Yes, here it is. So such type of order pairs 1 comma 1, 2 comma 2, 3 comma 3, x comma x, such type of order pairs always satisfies transitive condition. No need to check transitive condition for that particular relation. I hope you are understanding. So this order pair passes the transitive test. Now come to this. This ends with 2. Now you need to look any other order pair is there which starts with 2. Yes, here this starts with 2. Okay, 1 comma 2, 2 comma 3. There exists x comma y comma z. What is x comma z? X comma z is 1 comma 3. 1 comma 3 is there in this relation. Yes, here it is. 1 comma 3 is there in this relation. See, you cannot say this relation is transitive because of this example. 1 comma 2, 2 comma 3 implies 1 comma 3 belongs to the relation. That's why this is transitive. If you say like that, it is wrong. You need to check. You need to check for every such pair of order pairs. I checked this. This passes transitive test. Now I'm checking this element. This ends with 2. I'm looking that any other starts with 2. This is the only order pair starts with 2. This is x comma y comma z. X comma z is 1 comma 3. Yes, 1 comma 3 is there in this relation. Okay. So what I'll say here, I can say that this element passed the transitive test. That's it. Okay. Now come to this. Now this ends with 3. Right now you need to look that any other starts with 3. You see here, this starts with 3, this starts with 3. First I'll check this with this ends with 3, this starts with 3. Now what is order pair x comma z? X comma z is 2 comma 1. 2 comma 1 is there in this relation? No. So here you can stop and you can say that this relation is not transitive. Please catch the point. When it is transitive, you need to check for every such pair of order pairs, right? So as we identified one order pair x comma y comma z says that x comma z does not belong to this relation, then we say that this relation is not transitive. So R3 is not transitive. What is the reason why it is not transitive? Because 2 comma 3 is there in the relation and 3 comma 1 is also there in the relation, but 2 comma 1 does not belongs to the relation. Because of this relation is not transitive. I hope you understand why this relation is not transitive. You observe this relation R4. It is a relation on A because 1 comma 1 is there in A cross A, 2 comma 2 is there in A cross A, 3 comma 3 is also there in A cross A. So R4 is a subset of A cross A. So R4 is a relation on A. Now I need to check this relation is transitive or not. See, we'll check for every order pair. You see this 1 comma 1. This is a 1 comma 1. This ends with 1. Any other starts with 1? No other starts with 1. And moreover, we know that this type of order pairs always satisfies transitive condition, right? No other starts with 1. So we say that this pass transitive test. Now come to this. This ends with 2. Any other starts with 2? No. We say that this pass the transitive test. And this ends with 3. Any other starts with 3? No. So in that case, what we say, this element passes the transitive test. All the elements passes the transitive test. So in this case, we say that this relation is transitive. Now I taken one more relation. It is a subset of A cross A. So now I need to check this relation is transitive or not. Okay. Come to the first one. This ends with 2. Correct? This ends with 2. Now you need to look that any other starts with 2. Yes, here it is there. It starts with 2. 1 comma 2, 2 comma 3. What is x comma z? X comma z is 1 comma 3. 1 comma 3 is there in this relation? Yes, 1 comma 3 is there in this relation. From this, you cannot say that it is transitive. We can say that just this order pair passes the transitive test. Like that, you need to check for every x comma y comma z in the relation. Okay. Now, come to second order pair. This ends with 3. Any other order pair is there which starts with 3? No other order pair starts with 3. So we say that this order pair passes the transitive test. Now come to this. This ends with 3. Is there any other order pair starts with 3? No. In this case, we say that this passes the transitive test. And come to this. See, this is like 1 comma 1, 2 comma 2, 3 comma 3. In such cases, what we say, this type of elements always passes the transitive test. If you want, you can check, but no need to check. See here, this ends with 1. Any other starts with 1, this starts with 1, this starts with 1. First, we'll check with this one. This is 1 comma 1. This ends with 1. This starts with 1. What is x comma z here? X comma z is 1 comma 2. 1 comma 2 is there here. Now you see here 1 comma 1, 1 comma 3. I hope you are understanding. 1 comma 1, 1 comma 3. What is x comma z? X comma z is 1 comma 3. 1 comma 3 is there here. So that's why I'll say that for such type of elements, which type of elements? X comma x, 1 comma 1, 2 comma 2, 3 comma 3, such type of elements, no need to check the transitive condition. This always passes the transitive condition. So this element passes the transitive test. So R5 is transitive. I hope you understand this transitive relation. What is transitive relation? How to check the transitive relation? Next, equivalence relation. What is equivalence relation? A relation R on A is said to be equivalence relation if it is reflexive. It must be reflexive relation, and it must be symmetric relation, which is reflexive, symmetric, and transitive. If a relation is reflexive, symmetric, and transitive, then we say that that relation is equivalence relation. For example, you see here this relation. What is set A here? Set A is 1, 2, 3. 1, 2, 3. This relation, you observe, this relation is reflexive or not. As 1 is there in set A, 1 comma 1 is there in the relation, as 2 is there in set A, 2 comma 2 is there in the relation, as 3 is there in set A, 3 comma 3 is there in this relation. So this relation is reflexive. Now we know that this type of elements always passes symmetric test. What is symmetric test? Symmetric means x comma y belongs to R, means y comma x also must belongs to the relation, right? For 1 comma 1, reverse order also 1 comma 1, this type of elements always pass symmetric test. So this relation is symmetric also. As we discussed now, it is transitive. Yes, this relation is clearly transitive. So this relation is equivalence relation. Yes, this relation is equivalence relation because it is reflexive, symmetric, and transitive. I hope you understand this class. If you like this class, please drop a like. Share this video with your friends. In case if you are not yet subscribed to my channel, please subscribe. Thanks for watching. Take care. Bye bye.